Okay, and I'll go ahead and do
Meeting is being recorded.
audio captioning as well. So, okay. Hello, everyone. Welcome to today's event entitled Dealing with Problems Beyond Root Cause Analysis. I'm pleased to introduce Andrew Dixon. Andrew is the head of the Service Management Office at a little-known university called University of Oxford. I've had the privilege of knowing Andrew through our involvement with the Rugged Service Management Group. The Rugged Group is part of a cohort of select universities in the UK, and we've had a chance to work on a few projects together. Andrew recently wrote a very compelling and practical book on problem management. So I invited him here today to kind of share his insights that he learned from writing the book, reasons kind of behind why he put the book together, and really to give you a chance to ask questions. Now, reading the book wasn't required to attend this webinar, but if you did get a chance to pick up the copy, by the way, the link to purchase the book is in the meeting invite. You can purchase that on Amazon. So just gives you a chance to ask him questions. And yeah, I'm just pleased to bring him here today to talk about his book and practical ways of managing problem management. So we'll go a little bit about the overview of the presentation. So Andrew will give his presentation, last about 40 or so minutes. We will leave time over at the end for Q&A. Please use the Q&A to ask questions, but we will take them at the end of the presentation. Use the chat feature to talk to each other or talk to the panelists, but please be sure to ask your questions using the Q&A feature. It allows us to track and make sure that we're responding to questions appropriately. The webinar is being recorded and will be available on the EDUCAUSE ITSM Google website within 5 business days. All right, without further ado, I'll go ahead and turn it over to Andrew.
Thanks very much, Mitch. I appreciate this opportunity to talk to you about dealing with problems in an environment where root cause analysis may not be sufficient. In order to do that, I'm going to reflect briefly on how IT systems are becoming more complex and look at the differences for problem management between ITIL version 3 and ITIL 4. I'll explore a few side roads along the way before reaching chaos. And then I'll look at the role of root cause analysis and ask the question, how do we deal with problems which don't have a single root cause? We all know that IT systems have become more complex. If you think just about networking over the last 30 years, computers may not have been networked or may have been on an isolated LAN 30 years ago. Today, we have public cloud where virtual networks operate over physical networks, and without the internet, our work grinds to a halt. Development has transitioned from waterfall projects taking a long time to produce a defined application to agile projects delivering small improvements on a regular basis. And this leads to lots of small changes, and lots of small changes can create lots of small problems or big ones. So if we think back to ITIL version 3, possibly oversimplification of problem management was to identify the problem, do root cause analysis, and fix the root cause. Problem solved. And as part of that process, a workaround may have been provided, but in this talk, I'm going to ignore workarounds and just think about the root causes. ITIL 4 recognized that not all problems had a single root cause, and that the linear problem-solving route was not always adequate. And so it's introduced the Cynefin framework to recognize different levels of complexity. And I'm going to explore those different levels of complexity and ask what tools we need and what could we say about each one. So at the lowest level of complexity, we have simple problems where a playbook may be utilized to identify which of a number of known solutions should be used to fix the error. An example of this might be a PC that won't power on. And there are 4 obvious causes for a PC not powering on: the utility power, may have failed and the socket may not be live. So that's number one. Or number two is that there might be a problem in the mains lead. It might be the fuse. Or maybe the switch mode power supply has failed. Or maybe there's a problem with the motherboard. So you ring up, you get a repair engineer called out, and they work through the plausible scenarios and rule them out one at a time. And if none of the others apply, then they replace the motherboard. A purist might want to know why the motherboard's failed and what you're going to do to fix the motherboard. But as far as the repair engineer is concerned, they don't care at that point. They just replace the motherboard, the machine's fixed, and they send the failed one back to the lab for further analysis. And so simple problems have this playbook, a number of known solutions, you work through them, you get one that works, and you go home. The ITIL version 3 process is essentially the same as the ITIL 4 process for complicated problems, where there is a single root cause that's not obvious. And in my book, I look at the standard techniques for identifying a root cause for a complicated problem. And I look at a number of different techniques, including timelines. And my favorite, I have to say, is timelines. I always start with the timeline for a problem. But it's also useful to know the known failure modes and to be able to use standard techniques such as drill down and divide and conquer and rule out various possible causes. I'm also quite keen on the Ishikawa diagram, which allows us to look at cause and effect in a wider scope than just the technical, to ask whether there are other reasons, other causes for the problem rather than just the technical options. So I think it's worth thinking for a moment about the reason for doing root cause analysis. It's not just about understanding what happened and knowing how to fix it. It's also useful to know why it happened, because if you don't know why it happened, then you can't know whether it will happen again and how to prevent it from happening again. And there are a number of techniques which I look at in the book for understanding why problems happen. Failure modes looks at the technical aspects of a system and asks how the system can fail. Part of root cause analysis is determining which failure mode caused the failure. And that may be one that you previously knew about and accepted the risk for, or it may be an entirely new failure mode that you hadn't previously identified. Systems typically have resilience built in to mitigate against failure modes, but there will always be risks, and it's always worth reviewing those risks. And you will always have to accept some of the risks because we live in a world of limited resources. But not all causes are technical, and so Ishikawa diagrams help us to think through the non-technical contributing factors. And with that information, we can determine what is the likelihood of it happening again, and what, if anything, we should do to tackle the technical issues, the contributing factors, and the overall risk which results. If reactive problem management is about dealing with problems after they've occurred, I'm going to define proactive problem management as preventing instances of a problem before they occur. And a wise person learns from the mistakes of others. So one way of doing proactive problem management is to understand what problems other people are suffering from and identify whether your environment is susceptible to those problems. And this may be as simple as keeping an eye on what happens on Microsoft Patch Tuesday. And I think that subscribing to mailing lists like Educause, Usiza, and Rugged can also provide early alerts to potential problems. I also believe that using monthly reporting and metrics to identify trends is a good way to pick up potential problems that may lead to proactive problem management intervening early. As an example of that, a long time ago, I managed a teaching lab of computers that were used for CAD work, which needed non-standard graphics cards. And after a few years, we saw repeated failures of graphic cards. And we identified that they were all from the same batch. And we went back to the supplier, the machines were still in warranty, the graphics cards were supported. And we said to the supplier, wouldn't it be nice if you replaced the whole batch all in one go? And they said, no. But although they wouldn't replace them all in one go, they did agree to make sure they had stocks of the graphics card and that their repair engineer could replace the graphics card on a next day basis, rather than they come out, confirm it's a broken graphics card, have to order one in, come back a second time. So it was worth doing the analysis, even if I didn't get exactly what I wanted. Last year, we re-evaluated our electrical power resilience based on threats to the UK power distribution network. There were rumours that we would suffer 3-hour power cuts. And we looked again at the infrastructure within the university and said, will our infrastructure cope with 3-hour power cuts? And we'd always based our risks around 1-hour power cuts, because in the centre of the city, it was incredibly rare to suffer a power cut which lasted more than an hour. So we had to go back and redo our planning and say, actually, let's not wait for a 3-hour power cut. Let's put in additional resilience so that we can cope with 3-hour power cuts. We didn't, in the end, suffer any power cuts, but the work is in place for next winter. In terms of prioritizing of problems, I think that you shouldn't just prioritize problems on their own and deal with them on their own. But when you're doing proactive problem management, you need to see them as part of CI, continual improvement. And you should add them to the CI register and to the normal backlog of enhancement requests and prioritize your problems alongside your enhancement requests and ask, which is more important for the business? Is it more important for the business to have the latest enhancement? Or is it more important for the business to fix this problem before it causes disruption or downtime or inconvenience? And sometimes we'll go for the enhancement and sometimes we'll go for the problem. But I think that's a business decision and not a technical decision. And then we come to the world of DevOps. And my first admission is that Oxford doesn't do an awful lot of DevOps at present. It does a little bit of DevOps, but I want to ask whether the techniques that I use in the non-DevOps world actually work in the DevOps world, characterized by frequent release of lots of small changes. And I'm particularly interested in the organizations that we partner with, that are SaaS and cloud providers, and see how they deal with it. So I'm interested in organizations that we subscribe to who have multiple teams working on different layers of the technical stack, all making small changes to their part of the stack. And each small change could create a problem which testing fails to identify. Equally, testing of the components in isolation could fail to detect problems which are only apparent when these changes are brought together. Now, at this point, some of you will be thinking that the whole point of DevOps is that there's one team making all of the changes. And I understand that that is the concept. But in practice, if you look at the large cloud providers, life's never quite that neat and tidy. And some of the most spectacular failures of public cloud providers, for example, have resulted where the testing didn't take account of all of the environment and where several mistakes were made which aggregated together to cause a major outage. So I'm going to suggest that when a change made by a public cloud provider breaks their system, that the first thing that happens is that you run a simple problem process with a playbook, and the question that you ask is, did the change cause the problem? If it did, then you roll back the change. And we can all do that, and we should all do that. When changes fail, we roll back according to the agreed plan. But notice that rolling back an application should be easy, but rolling back data may be harder. If the change has corrupted data, then you can roll back the data, but how far do you roll it back? And you may not be able to recover new data. That said, I would argue that root cause analysis does not start until after the change has been rolled back and the service restored. So that's a bit like replacing the motherboard and then sending it back to the factory where they will analyze what component has broken and decide whether it's commercially cost effective to fix it or not. We may have changed the nature of problem management, but we've not changed the need for problem management. You may decide to throw away the motherboard if you can't fix it, but what about that bundle of small changes that different teams have been working on? Do you throw away the whole bundle, or do you just throw away the change that caused the outage? And how do you work out which one caused the outage without causing another outage? So standard techniques can be employed to find the change which caused the problem. I now want to think about complex problems, problems which don't have a single root cause. Some of these will have multiple root causes, and the challenge is finding them. And it can sometimes be a bit like walking through a maze. You may know exactly which direction you want to go in to get out of the maze, but you have to go in a different direction in order to progress. If there's a single root cause, and you think you may know what it is, if you try to fix that cause, then if that is the root cause, then it should fix the problem. And if it doesn't fix the problem, then that wasn't the root cause. But with complex problems, there's no guarantee that fixing one root cause will actually improve the situation at all. And it certainly won't fix it in all situations. So how do you know whether it's the right course of action or not? You may have to make the problem worse in fixing one root cause in order to be able to move forwards in order to fix the second root cause. And I want to give a real life example of a problem which had two root causes, although in the real life example that I'm going to give you, I could have fixed either one and it would fix the behavior for the users. So it was simpler than the more complicated variety. But what happened was that one day we started getting reports that some people couldn't log on to one of our corporate applications. The behavior seemed to be consistent for these people, but it was affecting some people and it wasn't affecting other people. And it was really not clear what the behavior was. We checked our timeline and there were no changes to the system which would account for the change in the behavior. And we did an initial scour of the supplier's knowledge base, and that didn't yield any information. So I was asked to pull together a problem board to look at the problem and try to understand the behavior, which was being seen on all environments across all different platforms. And the clue seemed to be that some people were clearing their web browser cache and then could log on successfully, but then other people were clearing their web browser cache and couldn't log on. So we had a little clue, but it wasn't a huge clue. Having collected more evidence and ruled out Windows updates and other possible causes, we realized that there was an interplay between our central website, www.ox.ac.uk, and the corporate application website, which also had an ox.ac.uk address. And the corporate application was inheriting cookies from the central website. It should have been ignoring the cookies, and in the past it clearly had been ignoring the cookies. But now it was crashing when it tried to parse one of the cookies which contained some JSON code. So there were two root causes. One was a bug in the corporate application that if it saw a cookie with JSON code, it crashed and wouldn't allow people to log on. And the other one was that our website was promulgating cookies to other corporate applications that really didn't want to consume those cookies. So we could fix either of those root causes and we would be able to restore service. We only needed to fix one. But in practice, we made the decision to fix both of them for a number of reasons. We knew that the corporate application was vulnerable to cookies that contain JSON code, so it was right to patch it to make sure that it wouldn't crash in the future. But we also didn't know whether or not this JSON code would cause other of our corporate applications to fall over in the future. So we blocked the inheritance to make sure that that couldn't happen in the future. And when we went back to the supply knowledge base, knowing what the cause was, we did actually find it in the knowledge base. And we found that there was a patch already available that could be applied to the system. We'd missed it the first time because we didn't know what we were looking for. And sometimes it's a needle in the haystack. But as IT systems become more and more complex, we will increasingly see more and more chaotic problems where root cause analysis isn't sufficient in order to fix the errors which occur. I believe, and I'm interested to hear from you later, whether you believe this or not, that the same problem-solving techniques may be applied to chaotic problems as are applied to other types of problems. But what we expect to achieve needs to be moderated. I also think that the challenge of IT going forwards is to design systems so that we avoid creating these types of problems. If we do not detect certain problems early on in their lives, then over time they will build up and cause chaotic systems for which there is no simple fix. Kuhnevin says, act and see what happens. So the question is this a good way to deal with problems, or will it make things worse? Do we have enough experience of chaotic problems to know what works and what does not work? And at this point, I am going to ask Mitch if he can launch a poll.
Absolutely. Poll 1 chaotic problem. You should see it on your screen. I'll give you about a minute or less to respond with your choices. Have you had to deal with a chaotic problem is the question. We're at about 20 some odd responding, just a few more minutes or a few more seconds to allow people to respond. And then I'll share the results. And then when you want me to turn them off or dismiss them, let me know, Andrew. So looks like we're about 75%, just 1 or 2 more seconds. Give everyone a chance to respond. All right, it looks like there's an overwhelming percentage. So I'm going to go ahead and end the poll, and you should see the results, Andrew.
Where am I going to see the results?
You don't see them?
Do you want to read them out? I think
maybe it's a browser thing. I can read them to you if you want. So 20 folks, 65% said yes, they've had to deal with a chaotic problem. 6% or 2 said no, and 9 people are unsure if they've encountered a chaotic problem.
Great, thank you.
Yeah.
Shall we move on to the second poll?
Oh, sorry, I didn't know they're on the same one. Yeah, let me go ahead and open that up for you. All right, so the second poll is handling a chaotic problem. If you were confronted with a chaotic problem, what would be the first thing you would do to tackle it? give you a chance to respond. There's 4 choices there. If you do want to respond with something else and other, please put that in chat. Andrew will pay attention to that as well. I think we've got a couple people responding. Give you a few more seconds to enter your selection. Got about 60% responding so far. Give it a few more minutes. Yeah, Kepner-Trago. Our university had the fortune of having formal training in Kepner-Trago. All right, we're at about 80%, climbing a little bit. I'll go ahead and stop the poll. I'll try sharing it again. Maybe you'll be able to see it this time, Andrew.
I found the button now.
Okay,
The button
cool.
appears when I click in the right place.
No worries. Do you see the results?
Yeah.
Cool. Okay.
So 45% say establish a timeline. Absolutely agree with that. 39% say make a change to experiment with a development environment. And I absolutely agree with that. 3% make a change to the production environment. I think there will be the odd occasion for that, but I much prefer playing with the development environment first. And 13% put a comment in the chat. And there are some good answers there, including asking questions of where is it and where is it not.
And looking for, Lee mentioned looking for patterns. So gather information first, look for patterns.
Thank you. Okay, thanks for that.
Did you want me to go ahead and stop sharing it so you can?
Yeah.
Okay.
And we'll carry on.
All right. Sounds good.
Okay. Am I good to go on?
Yep. I removed the results.
Great. Thanks. Before I think further about chaotic problems, I want to talk to you about a classic chaotic problem, and that's virus infection and malware in general. Once a system has been infected with malware, then generally speaking, the agreed consensus is that the best course of action is to wipe the disk and start again. But wiping the disk and starting again isn't always good enough. It may not clear the whole problem. And a few years ago, we experienced a 0-day virus infection, and we tried to follow the timeline and identify the PCs which had been infected and switch them off and clean them and rebuild them.
Andrew, are we still on slide 14? Okay, great. All right, slide 15.
Yeah, perfect. Just moved on. And we found that as soon as they were put back on the network and users connected back to them, they reinfected themselves. And it became apparent that it was not just the PCs which had been infected, but the user profiles had also been infected and they needed to be deleted. Some users had written files to network drives, and so those had been infected. And so when they went back to the network drives, they reinfected themselves. So although we managed to stop the exponential spread of the virus in a couple of days, it took longer to stub out all of the fires, which kept reigniting themselves. The timeline was essential in understanding the spread and in stopping it completely. And we found that failure mode analysis was very useful in identifying the contributing factors which we needed to address to reduce risk and impact of future events. And what became apparent in our post-incident review was that prevention was better than cure, which should be obvious for malware, but I also think that it applies to other chaotic problems. Once you have a chaotic problem, then unless you can move it to a complex problem, rebuilding from a known good state is probably the best you can hope to achieve. And even then, you may have rolled back time, but you may not have removed all of the underlying problems. So on this slide, I've given you all of the different modes of infection and all of the different steps that we had to take. No one of these steps was good enough to fix the virus infection. And of course, it didn't help that we were infected late on a Friday and that most people had gone home by the time it was realized that we had got a virus infection. So is root cause analysis dead or not? And I don't think it is. I think that the techniques that we apply to complicated problems are still relevant to complex and chaotic problems, even if we have to use them in a slightly different way and in a more nuanced way. And I think that we still need to start with the timeline. We still need to understand the failure modes for our systems and what the cause and effect is. And sometimes other techniques will work, like divide and conquer. Is it here or is it there? And sometimes they won't work. So as an example, I want to consider one of our applications which has a database measured in terabytes. And reports are run off it on a nightly basis when the load is lower. And we started having major performance issues with it at a particularly busy time of the year. We knew that we were loading the application more than normal, but the response to that was disproportionate. And some users found that forms were timing out, and other users couldn't even log on to the system because it was timing them out before they got to the forms. It was also clear that the overnight reports weren't completing by the start of the day, but that it wasn't just that was the problem, because even when they had finished, the problems carried on. So we formed a problem board, and we invite 3 different groups of staff to our problem boards. We invite the technical staff, because the technical staff are the people who understand what's happening and are the ones who are going to fix the problem. We also invite representatives from the business who know what good should look like and who can talk about the impact, who can agree downtime, and who can make some of the tough decisions. And then our problem boards are typically facilitated by my team. So this particular problem board had both the CIO on it and the head of the business area on it, so no pressure there. It was so critical to the university at that time of the year that they attended all of the problem boards in order to make sure that we were focusing the right resources on it. It's tempting to think that resources just miraculously appear, but sometimes it's good to have the senior people there who can make the resources available at the right time and say, yes, this is priority. This is what you're going to spend your time on. So we find that an integrated approach works well for us, although I'm quite happy that most of my problem boards do not have the CIO sat on them. So we first of all established a timeline of events, and the initial evidence was that the performance had started degrading a couple of months earlier, but had been tipped over the edge by the busy time of year. So we reviewed all of our changes within that period, and nothing seemed to be the cause of the issue. Further investigation suggested that performance had started to degrade a year earlier, but no one had noticed. So what had changed? Well, it was clear that this large database was constantly growing, and that at least part of the problem was the size of the database and the consequent size of the index files that it needed. From a technical point of view, it would have been fantastic if we could go to the university and ask them to shrink the database back to the size it was a few years ago. And we did. We said to them, can we just delete a few files, a few records, please? And they said, no. So we said, well, can we split it into smaller databases? And they said, no. That didn't work for them. So we had to look at alternative ways of solving the problem. their argument about splitting it into smaller databases is that they needed to query across the whole data range. And if you split into small databases, that just didn't work for them. However, it became apparent that the disk infrastructure couldn't cope with the IOPS demands being made on it. It couldn't get the data in and out fast enough. Well, we could have made some minor tweaks. We did make some minor tweaks to that. We made sure it was the only thing on that particular disk. And that helped a little bit, but not enough. And anything we did was just buying time, not fixing the problem. So it was evident that the database index system, which had once been optimized, was no longer running in an optimal way, and this was slowing down the whole system. So we now had 3 interrelated root causes. It wasn't just we had 3 independent root causes, they were interacting together, making the system all the more dreadful in its performance. So fixing 1 or 2 might buy us some time, but over time, the further database growth was going to aggravate the problem again, and it would come back. So we had to do something. And we tackled all 3 issues over the period of about 18 months. We bought new hardware. We re-optimized all of our reports, moving on to a new reporting tool at the same time to take advantage of new opportunities. And we also migrated our database onto the latest platform to ensure that it was optimized as much as possible. And I'm pleased to say that the service is working well now. But you can see that this was a non-trivial problem, that it required over £1 million being spent to fix it. And that's why we had senior members of the organization sat on our problem board saying, yes, this is the right approach. We will go and find the money to fix it. But above all, what it taught us about problem management is that it's not just about the technical fix. We did identify some root causes, but getting to a good state wasn't just about identifying the root causes and applying a technical fix to them. ITIL 4 talks about 4 dimensions of service management, and we need to understand our organization and its people. We need to understand how the university will fund major projects like this. Having the C-suite executives in the room meant that we could move forwards in a way that we couldn't have moved forwards if we hadn't had them in the room. And it was important to the university that we delivered value. So a neat technical solution would have been to stop the database growing, but that would not have met the needs of the organization. Equally, we couldn't fix the issue without working with our partners and suppliers. We could have applied sticking plasters to the problem with new technology, but it was only by working with our suppliers that we were able to provide a long-term solution. And I haven't talked about value streams and processes and the analysis work we did, but we did an awful lot of analysis work as part of this, and that was really important. So we touched on all 4 dimensions in fixing this problem. So in conclusion, I think that regardless of what your problem is, you start with your timeline and you understand your failure modes. You collect evidence, both positive evidence and negative evidence, and you recognize that there may be more than one root cause, but that above all, you use the same toolbox of techniques with your problems. Now, that's my view. And my question for you now is, do you think that that is right? And do you think that we should tackle chaotic problems that way, or whether we need an entirely different toolbox of techniques for chaotic problems?
So Andrew, I'm gonna we have a fairly small group, so if anyone wants to ask a question or answer Andrew's question, and please use the raise hand feature. I'll take you off mute, and when you're done asking the question, please put yourself back on mute. We don't have any questions in the Q&A, so as people are thinking of questions, I do have a question for you, Andrew. So how have you seen participating in problem management change with the use of cloud vendors? Like when they have a problem that they're trying to deal with, do you work with them in their problem management process, or is it more just interfacing through incident management?
That's a really good question, Mitch. For the really big problems that we've had with our cloud providers, we've got them in the same room as ourselves, and we have gone through the problems together. We've done the problem analysis together. We can't always justify that, and they won't always respond to that. But for the really painful ones, then yeah, that's what we've done. But it's very variable, and it's very much dependent on the cloud provider.
Well, I was going to say it probably depends on the nature of your relationship. In ITIL 4, they
Yeah.
talk about there's 3 levels of engagement with a vendor, right? One is your typical, and I forget the 3 types, but one basically is like a Google provider or Microsoft, where you get the service, that's what you sign up for, and you don't engage in problem management. They don't have you sit on their problem management boards. You just, report incidents to them. And others maybe more like a true partnership, where you're co-collaborating and you're creating value together, and you're working to work on problems together. So anybody have any questions for Andrew? Any other thoughts, Andrew, you want to share with the group? I have a couple minutes of Q&A, so can't see any hands. Oh, okay. So Susan, I don't know if it's a comment. Here, let me read it. Chaos increases in a federated IT environment. Yeah, using viruses as an example, with multiple IT groups responsible for endpoint management. One designated problem owner must coordinate and communicate updates, fixes, root cause, etc. One owner to unite IT. So she's just asking, and maybe from your experience, does Oxford or other people on the call have challenges coordinating, federated IT resources, right? Not just from a central group. Yeah, great question.
Absolutely. So when we had this virus outbreak, it was infecting machines across the whole university, with different IT teams in our federated setup having to deal with it. So we had a single team in the middle coordinating that and capturing the information and trying to triage it and detect who was being affected, and then having to go out to individual teams saying, these people from your department are infected, and this is the playbook, what you have to do in order to fix it. We also had some challenges, I have to say, because we've got IT services and we've got InfoSec, and the two are separate, and we were recording the incidents using different terminology, and it was very difficult to work out whether this was referring to different PCs being infected or the same PC being infected. But we were using, I can't remember, one team was using IP address and one team was using the asset tag, and relating across the two was problematic for teams where we didn't have access to their asset database. So yes, all good
process
fun.
Integration.
Yeah.
All right. So it looks like I don't know if you can see the chat. We'll take Tammy's question, and Okay, so Tammy's question, I'll address Charles' question. Yes, as mentioned in the beginning of the event, the session is being recorded and will be available on the ITSM CG website within 5 business days. So we'll go ahead and take Tammy's question and then give it a few minutes to see if anybody else asks a question. If not, then I'll go ahead and do the wrap up.
So in terms of root cause analysis, so the big problem that I talked about, the initial root cause, we were meeting on a fairly daily basis, and we identified that the disk IOPS wasn't coping, and we tackled that to give the business the headroom to be able to work within a week. So we got the business back up and working within a week, but we knew that we had just given them a workaround. And we met on a weekly basis for, I would say, another 2 months before we were confident that we really understood all of the root causes and what the options were. And at that point, it was quite clear that we needed a project and major funding. And at that point, we wound up the problem board and moved the problem into project management.
Yeah, I guess that question, the answer to the question really depends on level of effort, information and data you've collected, right? So, all right, well, Andrew, I appreciate your time. This concludes the presentation, and I want to thank Andrew for sharing his time and insight with us today. His contact information can be found on the deck. There's a link to the book that's included in the deck as well. I will be sharing the presentation along with the recording and the transcripts with you all within 5 business days on the ITSM CG website. You can go to that website and find all of our past recordings for many, many years. So it's a great place to find past recordings on any topic you can think of. Also look on our website and on the Connect platform for future events. As a reminder, on the 4th, we have an expert coming to talk about experience management. So very excited about that. And, you know, I'm always willing to, if you have a topic you want to present, come reach out to me. We can set you up. I always say, if you've got a message, I've got a stage. So thank you so much for attending. Thank you again, Andrew, and everyone have a great day. Bye.
Thanks very much.